All right, so get this bone regeneration.
Mm.
It's incredible. We're going to be diving into some research today by Dr. Alexandra Corboat.
Oh, wow.
Yeah, published in Polymers and Medicine,
Okay.
the Wroclaw Medical University. And
Wow.
she's using this technique called electrospinning.
Electrospinning.
Yeah.
Okay.
To create these incredibly thin fibers and get this, they're for building scaffolds that can actually help regenerate bone.
Wow. So like a framework to help the body rebuild.
That's what I'm thinking, right?
Yeah.
And what's even cooler is the combination of ingredients that she's using.
Uh-huh.
We're talking about biodegradable polymers,
Oh, interesting.
like PLLA and PCL, alongside a natural mineral that we already have in our bones and teeth,
All right.
hydroxyapatite or HAP.
HAP. Okay, so using things the body already knows and loves.
Exactly. Isn't that amazing?
Yeah.
But I gotta admit, this electrospinning thing, it sounds a little bit like science fiction to me.
Well, yeah, it kind of is. I
Did
mean,
you break it down a bit?
imagine like a super high-tech microscopic version of a cotton candy machine.
Oh, okay.
But instead of sugar, it spins these polymers into these ultra-thin fibers
Oh, okay.
using electrical forces.
Mm.
And these fibers then can be collected to form this mesh
I gotcha.
that mimics the structure that supports cells in your body, the extracellular matrix.
Right. So it's like creating a blueprint almost
Yeah, like a framework. Yeah.
for the body to rebuild the bone upon.
Yeah.
And I'm curious about these specific polymers, PLLA and PCL.
Right.
Why are those so important in this process?
Well, they're key because they provide that initial structure for new bone growth.
Okay.
But here's the best part. They're both biodegradable,
Ah,
so they break down naturally in the body over time,
interesting.
leaving behind only the newly formed bone.
Okay.
So like PLLA breaks down into lactic acid,
I see.
which your body just produces naturally.
Right.
So it's much less likely to cause any kind of side effects,
That makes a lot of sense.
which is a big deal when it comes to implants and things like that.
Right, yeah. It's like you're building a temporary support system
Mm-hmm.
that just disappears once the bone is strong enough to stand on its own.
Exactly. And that's where the HAP comes in.
Right.
Dr. Corbett has managed to incorporate a surprisingly high amount of HAP into these fibers,
Oh, wow.
up to 40% by weight.
40%.
Yeah.
That seems like a lot.
It is, and it's significant because HAP is known to stimulate bone growth.
So that seems like a huge jump from what I've heard of in previous research.
It is. It's a big jump.
Why is this high concentration of HAP so groundbreaking?
Well, think about it this way. The more HAP you have, the more bioactive the scaffold becomes.
Okay.
It's like sending a stronger signal right to those bone-building cells,
Okay.
attracting them to the scaffold and encouraging them to get to work.
Oh, I see.
A lot of previous research struggled to incorporate those high levels of HAP
Yeah.
without compromising the scaffold structure.
Right.
So this is a big step forward.
So it's like Dr. Corbutt kind of cracked the code,
She did.
found that sweet spot
Yeah.
where you get the benefits of a high HAP concentration
Right.
without sacrificing that strength and the integrity of the scaffold.
Exactly.
That's remarkable.
It really is, and it opens up so many possibilities for bone regeneration.
And I'm really intrigued.
Right.
Tell me more about the potential applications of this technology.
Sure.
Is it just about healing broken bones faster, or could it have a wider impact?
Well, faster healing is obviously a huge benefit.
Sure.
But imagine this. Personalized scaffolds that are precisely designed to fit like the shape of a bone defect.
Oh, wow.
So you're promoting even more complete healing.
Right.
Think about people with severe bone injuries
Yeah.
or those suffering from bone diseases like osteoporosis.
Right.
This technology could revolutionize how we treat these conditions.
So we could potentially be looking at a future
Yeah.
where debilitating bone injuries or diseases
Right.
are no longer these life-altering events.
Exactly.
That's an incredible thought.
It is, but as with any groundbreaking technology,
Right.
there are always challenges to overcome before this becomes like a reality.
Okay, let's talk about those challenges.
Sure.
What are some of the hurdles that Dr. Corbutt and her team are facing
Okay.
in bringing this technology from the lab to the operating room?
Well, scaling up production is a big one.
Okay.
Manufacturing these scaffolds on a large scale
Right.
while maintaining their quality and consistency, it is no easy feat.
I can imagine.
And then there's a complexity of the actual electrospinning process itself,
Right.
like selecting the right solvent.
Mm-hmm.
That's crucial.
Yeah.
You know, it directly affects the quality of those fibers.
Okay.
Too much, and the scaffold might be weak.
Right.
Too little, and you might not get those tiny pores that make it work so well.
Oh, okay. So it's like this delicate dance,
It really is.
finding that perfect balance of materials and techniques
Right.
to create these intricate scaffolds.
Yeah, and of course there's the rigorous testing
Oh, of course.
and regulatory approvals required
Right.
before these scaffolds can be used in clinical settings.
I understand.
Yeah.
So ensuring the safety and effectiveness
Yeah.
of any new medical technology is paramount, but
Right.
knowing that these challenges are being tackled head on is encouraging.
It is.
Yeah, this research feels incredibly promising.
Absolutely. And there's even more to explore.
Oh.
Dr. Corbett's work doesn't stop there.
Okay.
She's looking into incorporating even more bioactive elements into these scaffolds.
Now this is getting even more interesting. Tell me more about what those additional elements might be.
Well, that's a great question, but we're going to have to hold that thought for just a second.
Okay.
Because we'll be right back after a quick break to continue our exploration of Dr. Corbett's groundbreaking research.
Okay, sounds good.
Stay tuned.
We'll be right back.
So before the break, we were talking about some of the exciting possibilities with Dr. Corbett's research.
Yeah, it was getting really interesting. And you were about to tell me about some of the additional elements that could be added into the mix
Oh, yeah.
to make these scaffolds even more effective.
So it gets even more fascinating when you consider what's happening like at the microscopic level.
Okay.
With these scaffolds, like we talked about, mimicking the natural structure of bone.
Right.
Can you kind of elaborate on that a bit more for me?
Yeah, I'm all ears.
Okay, so our bones, they aren't just these solid blocks, right?
Right.
They have this really complex and porous structure,
Yeah.
almost like a honeycomb.
Eyes.
And this structure, it provides strength while allowing for things like, the transport of nutrients and the growth of blood vessels,
Okay.
which are obviously essential for bone health.
Right.
So Dr. Corbett's electrospinning process, it allows for the creation of this three-dimensional porous network
Right.
that replicates this natural structure.
So it's literally like creating a mini honeycomb within the body.
Yeah, exactly.
As this framework to encourage the bone to rebuild itself in this natural way.
Exactly.
Right.
And that natural structure is what we call the extracellular matrix,
Right.
or the ECM.
ECM.
And it's basically like scaffolding that supports the cells and guides their growth.
Okay.
And by mimicking this structure, Dr. Corbett scaffolds.
Right.
They
Okay.
provide the perfect environment
Gotcha.
for bone cells to attach and multiply and build new bone tissue.
So it's not just about like patching up a bone.
No, it's not a patch.
It's about restoring its full functionality.
Exactly.
That's incredible.
It really is. And
I'm curious.
Cool.
We've been focusing on bone regeneration.
yeah,
But could this electrospinning technology be applied to other tissues as well?
that's the beauty of it. It's versatility.
Oh, wow.
So while Dr. Corbett's research is focused on bone regeneration,
Okay.
the principles behind electrospinning can be applied to a wide range of tissues.
I see.
And by tweaking things like the types of polymers used, the addition of other bioactive components, and even the structure of the scaffold itself,
Wow.
researchers can tailor these materials to, very specific needs.
So it's almost like having a toolbox full of different building blocks
Yeah, that's a great way to think about it.
that can be assembled into these custom scaffolds for various applications.
Right.
Could we potentially see this technology used for something like cartilage repair
Absolutely.
or even wound healing in the future?
Absolutely. In fact,
Hi.
Dr. Corbett is already exploring
Okay.
adding even more bioactive components to these fibers,
Really?
like peptides, which are these short chains of amino acids
Yeah.
that can further enhance, the bone building power.
So it's like adding rocket fuel
Yeah.
to an already high-performance engine.
Exactly.
That's incredible.
Yeah.
But I want to shift gears a little bit
Okay.
and talk about the real-world implications.
Sure.
So what kind of timeline are we looking at
Well,
before these super scaffolds become a reality for patients?
yeah, that's the question. Yeah. It's always tricky to predict scientific progress, right?
Right.
But Dr. Corbett's research is a significant step forward.
Okay.
But of course, any new medical technology, it needs to go through rigorous testing and clinical trials and regulatory approvals.
Yeah, of course.
But the potential benefits of this technology, they're
Right.
just too significant to ignore.
Has there been any indication
Mm.
from Dr. Corbett's research so far, or even from other similar research,
Yeah.
that suggests that these types of scaffolds are effective
Right.
in a practical sense.
Well, her paper doesn't specifically delve into clinical trials,
Okay.
but her research clearly demonstrates the exciting potential of these scaffolds.
Right.
You know, the fact that these biodegradable polymers can be combined with such high concentrations of HAP, and they can mimic that natural structure of bone in a way that hasn't been done before,
Right.
makes this a very promising area for future clinical applications.
I can imagine. It's amazing how scientific breakthroughs like this can really spark the imagination. I can't help but picture this future
Yeah.
where personalized bone scaffolds are just the norm,
Yeah.
where complex fractures are just treated so quickly and effectively,
Right.
and the limitations that are imposed by bone diseases
Right.
become a thing of the past.
It's a vision worth striving for.
Right.
And while there's still work to be done,
Yeah.
Dr. Corbett's research is a fantastic example of how innovative minds are pushing the boundaries
It really is.
of what's possible in medicine.
It's a reminder that science is constantly evolving
Yeah,
and offering hope and solutions to some of humanity's biggest challenges.
absolutely.
Speaking of challenges,
Come on.
I'm curious about the cost factor.
Right.
These scaffolds sound incredibly sophisticated.
They are.
Are we talking about a treatment that will be accessible to everyone,
Sure.
or will it be limited to only those who can afford it?
Well, that's a crucial question, and it's something that researchers are very aware of.
Okay.
Right now, electrospinning can be a pretty costly process,
Yeah.
especially when you're dealing with these specialized materials and the need for such precise control.
Right.
But as research advances and production scales up,
Right.
there's hope that the costs will come down
Okay.
and it will become more widely available.
That's encouraging to hear.
It is.
Yeah. It'd be fantastic to see bone regeneration technology become as commonplace as setting a broken bone is today.
It would be amazing.
Indeed. And there's another aspect to consider,
What's that?
beyond the cost sustainability.
Right.
Remember, Dr. Corbett's work utilizes these biodegradable polymers.
Yeah.
This means they break down naturally in the body.
Mhm.
So you're reducing waste
Yeah.
and minimizing the need for additional surgeries
Right.
to remove implants.
Exactly.
So not only is this technology potentially life-changing for patients,
Yeah.
it's also environmentally conscious. That's a win-win in my book.
Absolutely.
Is there anything else about Dr. Corbett's research that you find particularly noteworthy?
I mean, one of the most fascinating aspects for me is that potential for personalization.
Okay.
You know, imagine creating scaffolds that are tailored to an individual specific bone defect.
Wow.
You know, optimizing healing and maximizing their functional recovery.
So it's like 3D printing a custom bone replacement
Yeah,
designed to fit perfectly with the patient's anatomy.
exactly.
That's the ultimate in personalized medicine.
It is.
It's incredible.
Yeah.
What other possibilities do you see on the horizon for this technology?
You know, as technology progresses, we can envision incorporating even more sophisticated features into these scaffolds.
Oh, well, like what?
Like things like controlled drug release, or
Amazing.
even like integrated sensors to monitor healing progress.
Wow.
The possibility is really endless.
It sounds like science fiction come to life.
It does.
It really does.
Yeah.
Dr. Corbett's work and the research happening in this field
Yeah.
are so inspiring.
It is inspiring.
This deep dive has been such an eye-opener for me,
All right.
giving me a whole new appreciation
Yeah.
for just the complexity of bone
It's amazing.
and the ingenuity it takes to create something that can mimic its structure and function.
It really is, yeah.
It really is.
It's a testament to both the elegance of nature
Why?
and the brilliance of scientists like Dr. Corbett,
Yeah,
who are unlocking its secrets and applying them to these real-world challenges.
absolutely. It reminds us that science is constantly pushing boundaries,
Mm-hmm.
offering hope for a healthier future for all of us.
Yeah, for sure.
You know, it's amazing to think about how far we've come in terms of medical technology.
It is, it really is.
Just a few decades ago,
Mhm.
this idea of regenerating bone,
Right.
using these kinds of bioscaffolds, would seem
Yeah.
like something straight out of science fiction.
It would, yeah, totally.
It really highlights the power of scientific curiosity and innovation.
Yeah. And the thing is, we're only just scratching the surface here.
Exactly, and that's what I find so exciting about this research.
Yeah.
It's not just about solving these current problems, it's about opening up these entirely new avenues
Mhm.
for treatment and healing.
Right. And it's not just limited to bone regeneration either.
That's true.
Like we talked about before, the principles behind electrospinning
Right.
and using biodegradable polymers with bioactive components
Yeah.
can be applied to so many different tissues and medical challenges.
It's like discovering this fundamental key that unlocks a whole new world of possibilities.
That's a great way to put it.
And I think one of the key takeaways from Dr. Corbett's research
Yeah.
is this importance of understanding and mimicking nature's own processes.
Totally.
It seems like that's a recurring theme in a lot of this cutting-edge medical research.
I think so, yeah.
Whether it's tissue engineering, biomimicry, or even new drug development, we're learning so much from just observing how nature solves problems.
Absolutely. And by combining that knowledge with this advanced technology,
Uh-huh.
we're able to create these solutions that were once unimaginable.
It really is
I
unimaginable.
know, it's crazy.
So I think it's safe to say the future of medicine is looking incredibly bright.
Yeah, it really is.
And research like Dr. Corbett's is really leading the way.
It is. It's really exciting work.
It is. It is. So for our listeners who are interested in learning more about this groundbreaking research,
Yeah.
where would you suggest they start?
I would definitely recommend checking out Dr. Corbett's full research paper in Polymers in Medicine.
Okay.
It's a really fascinating read. It goes into a lot more detail about the science.
Perfect. So we'll be sure to include a link to that paper in the show notes
Awesome.
for anyone interested in diving in a little deeper.
Right.